Okay, welcome everyone to the inaugural symposium for the Young Experts in Service Computing, YESC, for the IEEE 2021 Services Conference. For this symposium, we're going to have some of the leaders of the IEEE Services Symposium, YESC, to have some kind of a discussion about what it's all about and where we are going to head towards from here. My name is Kenneth Fletcher, and I'm going to be the host for today. So without wasting my time, I would call on Ron to begin.
Okay, thank you, Kenneth. Let me share my screen. Okay. Okay, I'm Ron Chen. I'm now the chair of IEEE Technical Committee on Services Computing. I'm also grateful for being the Congress General Co-Chair of the IEEE Services 2021. So at the beginning, I would like to share with you a little bit history about the YESC community of the IEEE TCS-VC. And this IEEE TCS-VC committee is actually created in 2018, about 3 years ago, with Sang Guang was as the first TCS-VC committee chair. Then at that year, we also started creating the so-called TCS-VC Rising Star Award. As you can see, listed there is the attendees of the awards since 2018. And the whole goal of this committee is really trying to promote the young experts, and including not just early professional career, only careers of the professionals, but also the students. Okay, so the rationale is, the service computing is a fast evolving field in both the technology and application. So we hope that we can provide a platform to help the students, even from in school, to start their career in the service company areas early and get all the help they can to grow their professional careers in this exciting area quickly. Okay, so I discussed that in 2018 with Shang Guang first about the idea, and he was very excited about the opportunity and also passionate about the young people. So he agreed to be the inaugural committee chair for the YES. Then next year we have Claudio also joined the committee as a committee co-chair with Sangguang together. Then our experience in the past suggests that we better have a chair to assume 2 years, while at the same time to have other new people, new leaders joining the committee. So you can see Sangguang then move on to the secretary of the TCS-VC in 2020. Then we have Kenneth and Yan join the committee chairmanship. Then in 2021, this year, we have Marco Anisetti to be a committee co-chair also. Now the social media was also created in 2018. So far, we already have more than 110 people join the YESC WeChat group. We also have a student ambassador WeChat group that already have more than 60 people, and it's growing gradually, not fast yet due to various reasons. We certainly hope that more people can join the YES community and benefit from what we can provide, and also get ideas how we can grow the communities even in an accelerated manner. So past activities includes doctoral symposium, PhD forum, and best yes papers at the IEEE services events. Then outside of the IEEE services event, we also have seminars and school visits, etc., to promote the supercomputing field in general, and also to get the young professionals involved in contributing to the advancement and application of these technologies. Okay. So the next chart is this is the couple of two important URLs for our community. The one at the top is the homepage URL of the IEEE TCS-VC, and you can see all the major items we have there, and we have been trying to make the content up to date. For example, all the recipients of this year's IEEE TCS-VC awards this year have already been listed there, including the past recipients and the awards chairs of the award. Then you can see that the committee is really open to everybody, and it's also free to join the committee if you just want to get involved and do not necessarily have the insights on who is who, and do not so that you don't really know who to vote yet. But once you think that you have a very good idea, even want to contribute more by being elected as an officer of the TCS-VC, then we will encourage you to really register as a member. Okay, then you have then you can vote for the officers. I'm very glad that Sang Guang is also going to assume the TCS-VC chair role from the beginning of next year and for the following 2 years. Okay. So this is the end of my presentation. I would like to pass my floor to Sang Guang.
Okay. So thanks, Ron. So yeah, I'm Shang Guang. So from BOPT. So first, congratulations to Zhang Ning get the Rain Star Award. So the award is very competitive. So I failed to get the award 3 years ago. So congratulations, Zhang Ning again. The award is for TCS-VC young expert. I hope more excellently young expert could get the award. So this will give a help for their professor career. So why is it the award? So I remember the second BOPT visiting at Man Cafe. You know, Ron? In 2017. So we talked more about the young scholar development. So we decided there should one platform for young scholar. So Ron and me established the Ron Experts in Service Computing Committee in 2018. So I'm glad to serve as the founding chair. So I think we should thank Ron's great decision. So yeah, so for the last 3 years, so I think IESC is very successful and attract many excellent young scholars, so such as Shui Guang, Rajev, Karuna, Xuanzhi, and Zhang Ning, so Kanish, Michael, and Claudio. So yes, so Claudio, he is the second IESC chair. So he did more valued work for IESC. So I think as chair, he did better than me. So I think the next chair is Kanish. So I think Kanish will do more better so than me and Claudio. So I wish yes better become better and better and growing and increasing influence. So thank you. So this is my panel. And okay.
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 So
you
so
do
I
the
want to,
honors?
yeah. So so sorry. I introduced Zhang Ning. Yeah. So yeah. So Zhang Ning. So next I introduce Zhang Ning. So Zhang Ning received the PhD degree in electrical and computer engineering from University of Ottawa, Canada in 2015. So after that, he was a postdoctoral research fellow at the University of Ottawa and University and Toronto, Canada, is respectively. So he is currently an associate professor at the University of Winnipeg, Canada. His research interests include mobile edge computing, Internet of Things, and security. He serves as associate editor of IEEE Internet of Things journal, IEEE Transaction on Cognitive Communication and Networking, IEEE System Journal, and a guest editor of several international journals, so such as IEEE Wireless Communication, IEEE Transaction on Industrial Information Informatica. He also served as a TPC chair of IEEE VTC 4 2021, IEEE SAGC 2020, as a track chair of several international conferences, in conclusion IEEE VTC, SEC, ANICO, and Collaborate COM, and as co-chair for numerous international workshops. He received the sixth Best Paper Award. Now he has been a senior member of IEEE since 2018. So next is Zhang Ning's dissertation speech. Okay, Zhang Ning.
Thank you, Professor Wang, for the introduction, and thank you, Kanish and Dr. Zhang for the introduction to about this platform. Let me first share my screen. And I would like to thank the award committee for giving this prestigious award, and I'm very, it's my great honor and pleasure to receive it, and really appreciate. And Professor Wang already gave a detailed introduction about me, so I'm going to skip the first page, and I will talk about generally talk about my research in the following 2 pages. And so my research mainly focuses on mobile edge computing and Internet of Things. So like in the following 2 pages, I'm going to briefly introduce my research. So in MEC, we mainly focus on computing offloading and content caching to support different services. And for computing offloading, we investigate several issues, several important issues, such as the deployment of MEC, task scheduling, and the resource management, as well as mobility-aware MEC services. And for deployment, we know that the service demand usually exhibit a spatial temporary feature. So deploying MEC server at optimal location and allocating MEC resources wisely play an important role to meet the service requirement. And in this regard, it is essential to learn the distribution of the resource demand in time and in space domain. And so in the first work listed here, we propose a spatial temporary based learning approach to learn and to predict the distribution of the MEC service demand over time and space to facilitate MEC deployment and resource planning. In terms of operation, we study offloading in dynamic MEC systems, and computation tasks with different requirements are dynamically generated by the end devices and offloaded to the MEC server in a time-varying environment. I mean, for instance, the workload of the edge servers, the wireless environment change over time. So in this dynamic environment, we propose a deep reinforcement learning approach to select the best edge server for offloading and to allocate the resources, computational resources, to maximize the number of completed tasks before their respectively deadlines. And in addition, we also study energy efficiency in MEC service. And we specifically, we formulate the problem as a stochastic optimization problem to minimize the energy consumption of task offloading while guaranteeing the average task queue length. So to deal with the challenges caused by the uncertainty and the dynamics of the wireless channel, wireless environment, and the task arrival process, and we apply Lyapunov optimization techniques to transform the original problem into a set of deterministic optimization problems and then solve them in an online manner. And consider the mobility of the mobility of the end devices, and we also devote efforts into mobility-aware MEC services. And we integrate microservice architecture in MEC, which allows us to provide small services that can be deployed and scaled independently to provide a better experience for the users. However, the user mobility can result in frequent switch of the edge servers, which can increase the service latency when the user move away from their serving edge servers. So to address this issue, we investigate microservice coordination among the edge servers to enable seamless and real-time responses to the request from the users. And we formulated the problem using Markov decision process, and then we propose a reinforced learning-based solution to coordinate microservice among the edge servers and to find the optimal strategy. For content caching, we know that edge caching can effectively reduce the latency when user requests the content and to mitigate the backhaul burden. So in edge caching, content popularity is very important for making caching decisions. And we study mobile edge caching with time varying and unknown popularity profile. And we observe that the user demand on certain content varying greatly at a different location. For example, the location can be divided into different categories with distinct social functions, such as residential area and business area. And users in different places can usually have different interests. So considering that, we design a learning-based location-aware caching scheme to maximize the total content hit rate. In addition, we also propose an online bi-directional deep recursive neural network for learning to predict the time series content request from the users and to update the caching, to update the content accordingly. In terms of IoT, we know that with the booming penetration of IoT devices in daily life, and a large like a wide range of applications are enabled, such as exchanging social information, sharing health data, and etc. And secure data exchanging between those devices has become a very challenging issue, considering the high security requirement and the low computational capabilities of those devices. So to this end, we study key agreements, authentication, and secure transmission to safeguard our key services. And for key agreement, we propose several peer-to-peer key agreement protocols, including the audio-based and movement-based key agreement protocols. And in audio-based key agreement, we leverage audio channels and audio signals to establish a symmetric key between two devices. Specifically, we generate the key by using the response of the audio channel between two devices, like between the speaker and the microphone. And two devices perform channel measurement, bit quantization, and reconciliation to agree a key. Okay, after that, the devices can perform a secure transmission using the common key. And we also propose a handshaking-based pairing scheme between wrist-worn smart devices. And the idea is based on the observation that by shaking hands, both wrist-worn smart devices have similar movement. So we capture the 3D acceleration data from the moment of those devices during the handshaking process, and then use those data to generate the key. And for authentication, we focus on signal watermarking based authentication, where typically a low power authentication signal is embedded into information signal for authentication. And however, in existing work, the text signal can be easily detected by the adversary. And so in this work, we apply a technique called a weighted frictional Fourier transform. We use this technique to Gaussianize the text signal so that the text signal looks like a noise to the adversary. And then we impose this Gaussian text signal into the message signal for authentication. And with this proposed scheme, we can achieve that the receiver can perform normal authentication, while the adversary cannot even detect the authentication text signal. And we also design several secure transmission scheme by exploiting the physical layer features, like the channel features, to overcome the eavesdropping and to achieve secure transmission on the active attacks. And so I listed those references here. If you are interested, you are welcome to refer to those articles. And again, thank you so much for attending this, for attending my my talk. And I hope everyone stay healthy and stay safe. Thank you so much.
Thank you, Ning, for your talk. So at this point, that's all that we have for this session. I would like to thank everybody. I would like to thank Ron, Shangguan, Ning, for making it a point to contribute to this session. And we will talk to you or see you all later. Have a good time.
Thank you.
Thank you.
Thank you.